So let's look at electric field lines. So electric field lines is a visual figure of an electric field and how they affect the region of space around a charge. So for example, let's say you have some kind of electrically charged object, and let's say this is positively charged. So this is an object that is positively charged. And then we have some sort of an electric field around this positively charged particle. So this is an electric field around the object. So if you think about the Earth, let's look at the gravitational field. If you think of the Earth, and if we draw the Earth, and then there's a certain region of space above the Earth that is affected by Earth's gravity. So this is the same kind of thing, but an electric charge. So let's look at how we can draw some electric field lines. So let me draw a charged object again. Let's say it's positively charged. And to look at the electric field, we need a measuring device. So the measuring device, as we learned earlier, is a positive test charge. So let's just bring a positive test charge close to the charged particle. And you see that they repel because our positive test charge is obviously positive, and the object we are looking at is positive. So the arrow at the positive test charge would be away. So this is an electric field line. Let's bring another positive charge somewhere here. And then if we look at what's happening here, again they repel. So at the positive test charge, our line is away from the charge. We can do this anywhere we want. This is the line. And you might see a pattern here now. Away from the object. So you see that if you have a charged particle which is positively charged, all the electric field lines are moving away from it. So what we can draw is that if we have a positive charge, our electric field lines are radially outward. So this is how we visualize our electric field. You can draw as many you want. And we say this is our electric field around this object. Now if you think of Earth, you know that closer to Earth there's a more gravitational pull than away from the Earth. Electric charges are the same. Closer to the object is the electric field is higher than away from it. The way to look at it is that let's look at somewhere closer here. Let's look at like a little imaginary box and see how many arrows can we catch. So in this little imaginary box we could catch maybe one, two, three, four electric field lines. Now what if we draw the same box, same size box somewhere here? How many arrows can we catch there? So if we just make these lines a little bit bigger, you see that you can only catch one arrow here, right? So from the number of arrows you can catch, which is completely arbitrary for each figure, but you can see like close to the charge you can catch 3 arrows, away from the charge you can only catch 1 arrow. This means that the electric field here, so let's just call it electric field at point A and electric field at point B, and then you see that electric field at point B is less than electric field at point A, which means the electric field is greater closer to the charge. So you can draw these little boxes and you can catch it. And like I said earlier, the number of arrows is arbitrary. So I could have drawn maybe 50 arrows around this, but the result would be the same away from the object. So by counting the number of lines, let me write it here. So by counting the number of lines in a box, and this box is imaginary, we can tell the strength, tell or compare the strength of the electric field in various locations.